Nikhil start ചെയ്തോളൂ.
Okay.
Nikhil?
Yeah, fine. Just starting now.
Yes. Nikhil, stop sharing. Okay. Very good evening and warm welcome to day 2 of our AI and data science webinar series. Today we have with us Professor Sri Geeta as panelist. Professor Sri Geeta M will show us how basic coding leads to powerful machine learning solutions. You will gain a clear understanding of how to start your journey into the world of AI and ML. She is currently pursuing her PhD in Information and Communication Engineering, Anna University, Chennai. She has done her master's in computer science and engineering from Nanda Engineering College, Erode. She has done her bachelor's in computer science and engineering from Sona College of Technology, Salem. She has 10 plus years of teaching experience as assistant professors in various institutions. She is currently serving in Amrita Vishwa Vidyapeetham, Faridabad campus in the School of AI as assistant faculty. She has also served in other universities. She has served in Manipal University, Jaipur, Kumaraguru College of Technology, Coimbatore, Tamil Nadu, Sri Krishna Engineering College, Coimbatore, India, United Institute of Technology, Coimbatore, India. She is apt in computer science adept in computer science with a focus on artificial intelligence and machine learning. She is committed to staying current in education trends, contributing to research and promoting a student-centered approach. She is an intelligent and enthusiastic educator committed to helping students accomplish academic goals. Her areas of interest in research includes artificial intelligence, machine learning, reinforcement learning, natural language processing, computer vision, algorithm. Some of her accomplishments include her project was the top 3 AI projects in the 6th national level technical project exhibition and completion conducted by Srishti in 2019 in St. Gates College of Engineering, Kollam. She was a winner of 1.5 lakh cash award in 72-hour AI hackathon conducted by Symbiosis Institute of Technology and Tata Motors, Pune. She also won third place with cash award of rupees 20,000 in Manipal MedTech Hackathon 2022 with a seed grant of 25 lakhs. These are some of her accomplishments. She has more to her credit. With this note, let us welcome Professor Sri Geeta. Ma'am, it's over to you now. Welcome, ma'am.
Thank you, ma'am. Thank you so much for the introduction. A warm good evening to all. It's like I'm thrilled to welcome you all to this exciting webinar series organized by Amrita School of Artificial Intelligence, Delhi NCR Campus. So it's wonderful to have you all here with such curious minds here today. I think especially your students from class 11 and 12, and I suppose like along with the students, the parents and few educators and tech enthusiasts have also joined the session. And today's session is like uh, the title of today's session is From Coding to Machine Learning. So even if you have never written a line of code before, so there are many AI and ML tools. So I'm just going to give you an understanding of what ML is and what are the basics and how your simple code can grow into something powerful that you can develop into AI agents. So it's like in recent days we are like more into the generative AI. We are talking about ChatGPT, the DeepSeek. So it's like the basis for all this is like the machine learning, the coding for this, right? So how are we going to do this? Even if you have never written even a line of code, it's fine. So with this note, let me just share my screen and we'll start on with the session. So if any clarifications or doubts, queries, you can just put up on the chat. So I'll be just going through it and answering your questions. So I suppose my screen is shared properly.
Yes, ma'am.
Yeah, thank you. So before starting this, so we'll just look into the base for ML is AI. So we know AI is a vast domain, and in which ML is a subset of AI, and ML also has this deep learning as its subset, and generative AI is the innermost component of the artificial intelligence, which we are all like talking about, right? So starting with the session, can I get a few response on this question? Like, what do you think artificial intelligence is?
And actually, this is YouTube Live, so they can mail their queries if they have any queries. So
Sure,
we'll
sure,
give
fine,
them an
fine.
email ID later on so that they can mail us their responses.
Fine, sure, ma'am. So what artificial intelligence is all about? So here I could say it's a combination of the computer science and the language, the statistical model put in together is what machine learning and artificial intelligence is all about. I want to build my machine's intelligence so that it can interact with humans like humans. So the basics of AI is to build intelligent machines that can interact with humans like humans. So this is what AI is all about and where it all started. So it means probably few of you have known about this scientist Alan Turing. So he had a query: can I make computers talk like machines? It means, can I make machines talk like humans? So there came the idea of Turing test. So what he did is that he was acting as the interrogator, and we have 10 responses who are attempting the questions posted by the interrogator. So out of those 10 persons, one of the persons were a machine. So where the interrogator couldn't identify that that it was a machine, it was answering exactly like how the rest of the other persons were answering. So it's like the machine was able to fool the interrogator that it was a human and not a machine. So this serves as the benchmark for many of the AI machines, the AI models, the AI agents in the previous stages. So this serves as the benchmark, so which we call it as the Turing test. So this served as the benchmark, and it led to the very basic chatbot, which is the Eliza chatbot, which acted as a psychological counselor. And even now, you could find this Eliza chatbot anywhere in online. You can just open a Google Chrome and you can just type Eliza chatbot, wherein it acts as a psychological counselor from the basic version till now. It means previously, before the generative AI was into the picture, it was conversational AI, right? So it was just making conversations with us, whereas generative AI next came into the picture. So from the conversational bot to a generative bot, now you can see all the versions of Eliza available in the online. So this is where it all started. And we know, like, completely AI had simplified our life completely. So whatever we look into, we have this AI product or AI application around us, right? So as I said, AI is nothing about bringing in computer program in order to make machines think and act like humans. So this is what AI is going to give the perspective, the different perspective to the machines. So I think, sorry, there is a lag in just moving it. Fine. Okay, so now this is where, so artificial intelligence, this is the vast area wherein we have machine learning as the subset, which is going to, it is nothing but machine learning. Now, this machine learning is nothing but the set of algorithms where we put in order to bring out the behavior of humans. And deep learning is again a subset of machine learning, wherein these are neural networks which mimics the thought process of humans. So as I said, AI is all about mimicking the behavior as well as the thought process, right? So here machine learning brings out the behavior of human, and deep learning brings out the thought process of the human. And generative AI, it brings the creative component of humans. So this is mimicking the creative component of humans. So this is all about the vast domain artificial intelligence. So as I said, this is the 4 ways that making 4 views of AI, making the machines think humanly, think rationally, act humanly, and act rationally. This is what we are trying to do. What is acting rational and acting humanly is all about? So there is one difference. Like, we used to have this proverb, to err is human, right? So even humans commit mistakes, humans do errors, right? So here we want our machines to act as humans, but what are all the actions they are performing for the given scenario? What are all the agents are performing the actions for the given scenario? It has to be right, it has to be rational. So instead of building human like agents, we are like building rational agents which has the intelligent quotient of humans. So this is what the entire idea is all about. So now let me just give you an overview. So as I said, AI is all about building agents for any given environment. So what are agents? Agents are nothing but, you can imagine them like, if I say artificial intelligence to every one of you, we get this idea of the humanoids, right? So humanoids are nothing but, you have the software program which makes it do all the functions like humans, and you have an architecture which is the physical structure for the humanoid, right? So we have the hardware component, we have the software component, and put together, they perform any activity that has been meant for that particular agent in the given environment. So how are we going to build it? This overall perspective is about agents. And here it is nothing but, as I said, agent is architecture plus program. And what is the program all about? I have a sensor. It means any agent have a sensor, and only through the sensors, like how we have our sensory organs, eyes, nose, ears, through which we perceive our environment, right? So we perceive the environment through our sensory organs. Likewise, the your robots or any agent, they are going to perceive the environment through the sensors, and they are like going to do some process, and that process again is converted into actions. And how are we performing actions in the environment? We have our locomotory organs, which are like hands, mouth, like leg. We have our it means organs in order to perform the actions, right? So these again, these agents, they'll be performing actions through the actuators. Okay, so this is all about agent is sensors perceiving uh, the inputs percepts from the environment, and they are going to be converted into actions through the actuators. They'll be putting it again back to the environment. This is how, this is the basic function of any agent, and this is what any AI agent we are like trying to build up. Okay, say for example, if it is a vacuum cleaning robo. Okay, so what is a vacuum cleaning robo? It is going to do the sensors, they'll just perceive whether dirt is there or not. If dirt is available, it is going to suck. If dirt is not available, it is just going to keep on moving to the other locations, so that in order to find the dirt and suck, right? So this, the sensor that is used to identify whether the dust is dirt is present or not are the things, the perceive, the percepts, I say. And the actuators is nothing but the vacuum through which it is going to suck the dirt. Okay, so these are the sensors and actuators, like they form the AI agents. Okay, so how ML DL is going to pave way in order to build these agents is what, like I'm like going to give an overview. We spoke about agents, so we need agents to be built up for a particular environment, right? So how my environment should be, I can say an environment should be like it should be observable, like it should be observable, fully observable or partially observable. Say for example, when you're playing a chess game, okay, uh, many of the times you will be playing against the computer, right? So when you are playing against the computer becomes the agent there, the software chess playing agent there, wherein it you can observe the environment completely, all the chess, uh, both cells. Okay, so they are fully observable. Whereas when you take a self driving car, what happens? Self driving car as an agent, it is just going on the road, and it doesn't know when a pedestrian will come across or when an animal will cross. So there I cannot completely observe the environment, so that is partially observable. So I need to completely understand the environment thoroughly with its properties in order to build agents for that. And we have, when I say AI, we have two types of problem. One is the toy problem, another one is the real world problem. So this toy problem, what it does is, we solve these small set of toy problems in order to solve real world problems. So this is a classic example where n queen's problem come into picture. So you can just see n queen's problem is nothing but placing n queens in an n cross n board. Say for example, if it is a 4 queen problem, I need to place 4 queens on the 4 cross 4 board, so that they are not in an attacking position. What is attacking position? A queen can move horizontally, diagonally, vertically, like anywhere in the board, right? So these are the attacking positions. I should not keep my queens in the attacking positions. Okay, so why do I need to solve a toy problem in order to solve a real world problem? It means nowadays it's all about IoT. And whenever I'm talking about this VLSI, this is very large scale industry, the chip manufacturers. So even a microchip, a nano chip contains n number of components, like 10 thousands of components, like resistors, capacitors, all should be placed in its position, so that we get maximum efficiency out of it, out of that particular nano chip, right? So by solving this toy problem, the n queens problem, that paves a way and gives an idea of how to solve uh, a, a VLSI layout problem. Okay, so in this way, we solve many toy problems, which gives an idea to solve real world problems. And when I'm talking about this AI, we all know that it is categorized into narrow AI, general AI, and strong AI. So when I say about narrow AI, any agent that is given only one particular task. Say, for example, we were discussing about the vacuum cleaning agent. So if I take vacuum cleaning agent, it is a narrow AI because the only one task that it is going to do or that it is going to perform is just to check for the dirt and clean. So that is the only task that it is doing. So that is narrow AI. So as Indians, like we in India, we have surpassed narrow AI. We have many, it means AI agents which performs this narrow AI task. And now we have been moved to general AI. So what is general AI? So any agent that performs more than one task can be put under general AI. And strong AI, these are agents which surpasses human intelligence. Okay, so that is what strong AI. And research, many countries, they have started their research in strong AI, but still we are still in general AI, wherein we are exploring it. So this is the classification of AI. And now comes, like as we said, there are many different domains in artificial intelligence, which we say as the machine learning, deep learning, natural language processing, computer vision, speech, and robotics. And why do we need all this? So, as I said, AI is all about mimicking human intelligence. So, when do I say a human as an intelligent person or an intelligent person? When I say he is able to learn and he is able to think, when he is able to logically reason and provide any solution for a problem, when he is able to clarify his thought process through a proper communication, uh, and he is able to perform actions properly. So these are the components that I can put into human intelligence, right? So if I say I'm mimicking this human intelligence, so obviously I want my machines to do all this exactly, right? So that's where, so he or she, if it's capable of learning, so that learning ability I'm providing to my machine through the component machine learning and deep learning. And the ability to speak, the communication is through natural language processing, and the ability to perceive the environment, to read something from the environment, to logically think. So there comes deep learning and computer vision. And robotics, like we perform actions, right? So now we'll move on to the main part, which is the machine learning. So as I said, AI is to mimic human thought process and behavior. So now here machine learning is going to provide that ability to my machines, wherein I'm going to make my machines auto learn from the experience where I don't have to code it. Okay. So you can see a GIF running here, and here a man teaches an agent look saying that, showing an apple, that this is apple, right? So he is showing few images of apple and saying that this is an apple. I think you can see now it is trying to learn all the features by itself. So he is not saying that apple is red, the apple is round. He is not saying anything, but he is introducing a new image and calling it as an apple, right? So the machine itself is learning the feature. And whenever you see a different image is shown, and now the man is not nearer to the agent in order to say that even if it is not red, it is an apple. So you can see the machine is identifying it based on the features that the man has taught through the images that it has already learned. Okay, so this is the auto learning process. Even if we are not available there, it auto learns, the machine auto learns from the previous experiences, and it is trying to put up the human behavioral process. This is what machine learning is all about. So when we talk about machine learning, we do have programming for machine learning. But how come machine learning differs from the traditional programming? So in traditional programming, so being students of 11th and 12th standard, like you would have done computer little computer codes. So generally what we do was, say for example, I'm like coding um, using any programming language like C, Java, or Python, whatever the programming language might be. Okay. So I'm just coding a very simple program to find sum of two numbers. So what in traditional programming I will do is that I'll give the code. Okay. So here you can see, one second. Okay. So here you can see that I'm providing the data. Okay. X is equal to 1 and X is equal to 2. I'm providing the data and what has to be done with the data. So that I call it as the rule, which we call it as the coding. Okay. So here what I'm doing, I'm saying that the data has to be multiplied with 2 in order to produce some output y. So y is equal to x into 2. I'm providing the rule as well as the data so that your machine provides answer y is equal to 2 and y is equal to 4. Okay. So this is what traditional programming is all about. I give the code, I give the data, I tell the machine what to do. The code tells probably the machine what to do, right? Like find sum of two numbers or do a matrix multiplication or try to find out the prime numbers between 1 to 10, do a factorial for any given number. You will give the code and the data. So it puts the data into process and it provides some output. So this is traditional programming. But what happens in machine learning is that instead of giving the data and the rule, I'm going to give the data and the output so that I want my machine to learn how the data or what is the process behind that has happened in order to make the data transform into that particular output. So here you can see what I'm giving to the machine is data x is equal to 1 and x is equal to 2. And the answer, which is y is equal to 2 and y is equal to 4, the data and the output. So this is what I'm giving to the machine, and I want my machine to think and how this data has become the answer. So how 1 has become 2, what I should do in order to make my 1 to do into 2, it means to transform that into 2, how my 2 has become 4. So obviously it finds the common hidden pattern how my data is transformed into the output. So here the hidden pattern is multiplied by 2. So it derives that rule by itself. Okay. And this is what I call it as the model. The rule it derives is what I call it as model. So now if I get that model for any data, I can get the answer. I can get the output, right? So this is what I want my machines to learn. Traditional programming, I'm giving the data and the rule, getting the answer. But whereas in machine learning, I'm giving the data and the answer and making my machine to learn how the data has transformed into that answer. So that is what the basic ultimate machine learning is all about. So when I talk about machine learning, we have different types, different forms of machine learning, wherein I'll show codes for some of these learning techniques. So first comes the supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So these are some of the types of the major learning types in machine learning. So when I talk about supervised learning, so what is supervised learning? From the name itself, you can identify that supervised learning. I'm going to make my machine learn with some supervision, right? So here you can see um, there are mails which are labeled as not spam and spam, right? So these are collection of mail. I have a collection of mail under the label not spam. I have a collection of mail under the label spam. So I'm like going to give these collection with the labels. Okay. So these labels are going to act as the supervisor. Okay, so they are going to supervise the learning, which means they say that these mails are not spam and these set of mails are spam. So I'm like going to pass this data to my machine and make my machine learn. Okay, so it finds the hidden pattern as we saw in our previous slide. So it finds the hidden pattern why these mails are put under not spam category, why these mails are put under spam category. So, it means, for example, the spam category might have mails of longer lengthy male body, or it can have too many images, or it can have words like offer, discount, loan. So um, so these types of features, it tries to learn that hidden pattern, it tries to learn by itself, and it forms a model. Okay, so now you can treat this part as the model. So you can see new incoming mails, I'm like passing it. So these mails, I'm not labeling it. You can see here I have labeled. When I'm giving it for the learning purpose, I'm labeling it as not spam and spam. So once the machine has learned, I have converted that into a model, and to this model, I'm like giving mails. I'm not telling whether it is spam or not spam. Now, with the help of experience that it has learned from the supervised learning, now it can categorize whether the new mails that are incoming or spam or not spam. So this is supervised learning. So supervised learning is all about I'm making my machines learn with a supervision, which are the labels here. The next technique is the unsupervised learning. So what happens in unsupervised learning? Again, the name itself suggests unsupervised. So now here, even I'm not going to give those labels, which I call it as the supervision, right? So here I'm not going to give those labels also. I'm just going to give all the data and let the machine figure out and find the similarities and dissimilarities. If they are similar, put it under one cluster. If they are dissimilar, like segregate them and find what are all the similar categories available and put under it. So here you can say we have different ducks and the rabbit images. Okay, so it is trying to figure out the hidden pattern, like say for example the features like nose, it has a beak here, whereas rabbit does not have a beak here. And the foot might be the flat foot or the web foot. Okay, so the body structure, so it is trying to learn from the feature, and itself is trying to categorize or cluster, okay, group them into clusters based on the similarities. So this I call it as the unsupervised learning. Okay, and semi-supervised learning, again the name itself suggests what is semi-supervised learning. So I'm going, it's a kind of partially supervised learning, right? So wherein, say for example, um, the in supervised learning, what did we see? Like 1,000 mails we have, 500 mails I'm putting it, let the 500 mails be not spam, let 500 mails be spam. Okay, in spam folder I'm like giving labels. But what if I do have 10,000 emails with me, wherein the labels are available only for certain data? Say for example, only for 100 emails I have whether it is spam mail or not a spam mail. I'm having it means labels only for those data, and remaining 9,900 data, they don't have any labels at all. So now what I can do is I can make my machine do the supervised learning and understand the pattern, how they are classified into spam and not spam, and with that knowledge do the same, create pseudo labels, create false labels, pseudo labels for the remaining 9,900 data that do not have any labels at all, so that you can automatically classify whether it is a spam mail or a not spam mail. Okay, so this is semi supervised learning, wherein I have partial data with labels and the remaining data I don't have any labels, so that I make my machines create pseudo labels. So this is semi supervised learning. Okay, so create pseudo labels, train on them, and then again I'm creating a pseudo labels for them. Fine. And the last and final technique is the reinforcement learning. Here in reinforcement learning, you can see there is an agent here, and you have an environment, and in the environment you have fire on one side and the water on other side. Now just imagine, we tell a child like fire burns your fingers, but it does not have any experience like what is burning, right? So it will have the curiosity of just going and touching and experiencing how it feels, though we say it has to experience on its own to not to do that action again, right? So here similarly I'm allowing my agent to do all the actions. Might it be fire, you can go near the fire, you are supposed to touch the water also, I'm like allowing you to perform both the actions. Okay, but the feedback given by the user. Say, for example, if it is going and touching the fire, I'll be giving a penalty because that is a bad action. Don't do that. And if it is going near the water and touching it, I'm going to reward it. So this is a good action. You can just go and do it. Okay. So I'm allowing the agent to experience everything. And how does the agent understand that it is performing the right action or not? It is based on the reward or penalty that the user is giving. Okay, so here you can see minus 50 points, and here when it is going near the water, I'm giving plus 50 points. So based on the reward or penalty that it is receiving, so it can put up the actions that these are good actions. I can just perform that again and again. Okay, so this is what reinforcement learning is all about. I hope you just got an idea of the learning types. Okay, and then comes the neural networks. Okay, so these are statistical models. The machine learning algorithms are mostly based on statistical models, whereas the neural networks actually, so when I say neural networks, you people immediately think of the neural network in the brain, right? Neurons in the brain. So how are neurons connected to every other neuron? Okay, so how for every action there is a stimulant in the neuron, so that the information is just being carried as signals to every other neuron. What is happening in the brain? Okay, so that mimicking of the human brain operations or the process, that we call it as the neural networks. I'm mimicking the thought process, so that becomes the neural networks. Okay, so here you can see the difference between a biological neuron and an artificial neuron. So if I say artificial neural network, okay, so that becomes the deep learning. When I say artificial neural network, how am I mimicking the neuron, the natural biological neuron structure to an artificial neuron structure? So this is just to give an idea. We have the dendrites. So probably you would have seen what is all this. So you have this neuron, you have the dendrites carrying the signals, and the cell body actually performs or process on the signals that it is receiving, and all the information are carried across this axon, and this, through this terminal axon, every neuron is connected to every other neuron, right? So this is how the process carries on. Fine. So how this is happening? And when I'm saying deep learning, you can again think, I'll not it means as a kid, we all would have had the experience of eating what we call it as nilachore, like looking at the moon, sitting in terrace, and just looking into the enjoying the environment and the nature, and just having our dinner, right? So their mom used to say, this is tree, this is moon, and whatever it is, like passing on the road, this is a car. So used to say, what this child brain used to do, it just captures the image and store it with the label, right? So if I say this is car, I'll capture the image. Somehow the neurons in the image captures, and it store it with the label. Okay, so this is car, this is how a car look like. Okay, so no mother will sit and say that if this is a car means it has four wheels, you will have windows, you will have doors. It's not that. Just keep on looking into certain things, it get registers with the label that we repeatedly hear, the label along with the object, right? So this is what is happening. So how am I going to mimic this? In order to just show that, I'll show you a very interesting tool. Ma'am, can you confirm me, like, what is seen on the screen? Is it teachable machine?
Yes, ma'am. It is teachable machine.
Yes, thank you. So okay, so here you can see when you just open Google and type teachable machine, you will just find something very interesting. Here, as I said, I'm like having categories cat and dog. And here you can see the upload button. Since it takes time, I have already uploaded certain images here. I'll tell you how actually it is working. Okay, so here you can just use the upload, and I've already uploaded images. Let me just so you can see here, I have already uploaded. So cat images, I have like kind of 10,000 cat images. So I have already downloaded and I have uploaded it here. Similarly, I have dog images and I've uploaded under the label dog. Okay, so you can see here. So this has 12,498 cat samples, and here it has 12,499 image samples. Okay, and here I'm going to train the model. So what I mean by train the model is I'm going to give these many number of cat images and these many number of dog images to the machine. You are going to identify the hidden pattern. Why am I saying that this image belongs to a cat label and why this image belongs to a dog label? You are going to identify the features on yourself. Like if it is too furry, then it is based on the shape of the ear, based on the tail structure, based on the body structure. Okay, so you are going to identify the features by yourself and try to find why these images are put under cat category and why these images are put under dog category. Okay, so here I'm going to train the model. And what does this epoch says? What does the meaning of epoch? What is the meaning of batch size? What is the meaning of learning rate? So epochs, like say for example, you're like, you would have given the 10th exams, board exams, right? So before attempting any exam, like say for example science exam you're like going to give, how many number of full book revisions you would have done? Yes or no? So it's like I would have revised my book thoroughly, like from the examples to the book back exercises, everything thoroughly. Say for example, like 4 5 times I have completed. So that full book revision is what I call it as epochs here, which means if the 12,000, if there are 12,498 images under the label cat, and I set the epoch as 5, all these images will be completely learned by your machine 5 times fully. It will go through all the images 5 times in order to learn the hidden pattern. Okay, so you can set it 5, you can set it 10, like based on how many number of times you are making the machine to learn, it learns as many features as it can. Okay, and batch size, say for example, again let's move on to the example. I'm like sitting for 1 hour to study science. In that 1 hour, how many number of chapters or pages I'm like learning? So that I call it as batch size. Okay, so when I'm doing an epoch, how many number of samples that I'm going through every time? Okay, so that is batch size. And learning rate, what is learning rate? um, okay, so you have given up the science exam, you have received your marks, you have your answer script. Now somewhere you have lost your mark, so you want to do a revision again for the part where you have committed mistake, right? So only for that part I need to relearn it. Okay, revise it again, not the entire book, right? So the learning rate, how far you are minimizing it, you will learn only that part. If you are increasing the learning rate, you are unnecessarily putting in many pages or many samples in order to do the learning wherein it overfits. Okay, so this learning rate should be minimal, wherein I'm setting it as 0.01. Okay, I think you got an idea. Epochs is how many number of times I'm going to run all the images in order to make my images, in order to make my machine learn. And batch size is one time, in at one time, how many number of image samples that I'm sending it through. And learning rate, keep it minimal so that it learns, uh, it is learning when it commits a mistake, again it has to rectify it. So that learning rate should be minimal. It means you have to set the value as minimal so that only that part is like kind of revised. Okay, so I'm like going to train the model. So now it is training in the sense it is picking up all the images. Since I have set the epochs as 10, all the images completely will be run 10 times so that it learns the hidden features. Okay, so meanwhile, let the training happen. Okay, meanwhile, I'll share few other things. Like we were talking about supervised learning and unsupervised learning, right? So here is a small code. So what I'm doing here is I'm having some inputs X and the output Y. So I think you people remember that in machine learning, we give the input and the output, and we want the machine to learn the hidden pattern and come out with the rule, right? So that we call it as the model, and that we put as the model finally, right? So here what I'm trying to do is I'm giving the input and I'm giving the output. So you people probably know what is a straight line equation. Y is equal to mx plus c, where m is the slope and c I call it as the intercept. Okay, so I think you people know that. And here in supervised learning we have two techniques. Okay, so two major techniques, which is classification and regression. So now what this regression does is that I'm like plotting. If the value of x is 5, the output is going to be 99. If the value of x is 7, the output is going to be 86. Okay, so as such I have certain values of x and mapped to certain values of y. So here you can see this I call it as the scatter plot, the dots I'm having here, or the scatter plot. Say for example, for 5 the value is 99, and you can see for 5 the value is 99. So here is the dot, you can see. So likewise I have plotted everything. So this I call it as the actual outcome, because here I didn't predict anything. Actual input has some process has been made, and that's been converted to the value y is equal to 99. And see, now I'm calling on the function regression. Here linear regression is nothing but what you call it as y is equal to mx plus c. Okay, so that's a straight line. Okay, this straight line equation. So this I have to find it out. So I'm calling this function wherein I have y, I have x. So from this, it tries to put up and adjust the slope and intercept accordingly so that it matches all the values approximately. Okay, so I'm trying to find out what is the slope and what is the intercept. And I'm like trying to bring this straight line. This line, I call it as the regression line. Okay, so this is the predicted outcome. Okay, you can ask, ma'am, what I can use this for? Say, for example, you need to decide on something, whether you're going to rent a house. It means you're going to rent a house in a particular locality or not. So you will have certain features like what is the location, what is the area of the house, area in the sense the square meter area. So what is the square meter area of the house, how many number of bedrooms are there, what is the size of the living room. So based, you'll have n number of features, and you'll have to make a decision whether you are going to rent that house or not. Okay, and you'll also have to predict the price. So what will be the price? Say for example, if you are getting in a posh area, 3 bhk is available. I think you people have come across the site called 99 acres and all. So there, when you just choose the area and the number of bedrooms you want. uh, it means 3 bhk or 2 bhk. It predicts the price, like this will be the price of the house that you're going to live, right? So how it is doing, it is all because of this technique, which I call it as the linear regression. So the actual outcome where how 5 is made into 99. Okay, so based on that, I'm trying to make my machine learn what is the slope and intercept using this function linear regression, and it is going to return. And with that, I'm going to do a model which I call this as the regression, which is the predicted model. So there are many examples wherein you use this. So before that, let's see whether our model is trained or not. Okay, so still the training process is going on. So once the process is done, we will have our model ready here. As I said, it has find out the hidden pattern, like how it has been converted. It means with what features these images are put under cat and these images are put under dog. It understands and it creates a model here. When I randomly download some images, some image of a cat from Google and upload it here. Okay, let's just wait for 2 more minutes and see. So when I just upload any random images of cat or dog, let's see whether it has learned properly or not. If I upload a cat image, it has to show with full confidence that it is a cat. It has to label it as a cat. And if I upload a dog, it has to it means label it as a dog, which means it has learned all the features rightly. Because as I said, one of the feature that with which I can say that it is a cat is the cat fur, right? But we do have furry dogs like Pomerian and all, wherein we couldn't differentiate properly whether it is a cat or dog. But I'm letting the machine itself to learn that how it is going to do it. So you can note it down. This is teachable machine. You can just try it out and see. And you have Google AI Studio. So probably you would have all come across ChatGPT, DeepSeek, probably all would have used DALI, all these OpenAI and Google products. So there is this Google AI Studio also, wherein you can try to build your models, and this is what we do teach here. And so meanwhile, it is training. So here what we do is uh, our final examinations are completely based on the project based learning. So whatever we teach, you implement it. Instead of like we don't want you to write it with the pen paper just mugging it up. So it's not the case here. So right from the first semester onwards, whatever you are learning, you are just we are just trying to put it into a project. The final end semester examination here, it is a project, completely project based learning, wherein whatever you learn, you'll be putting up into a project. So we had introduction to biological data. Say, for example, that's a course here wherein you try to work on all the biological medical images or medical data. Okay, so here our first semester students, they did wonderful projects applying all these techniques, visualizing it, categorizing whether a particular cancer image has a cancer or not, which means a particular liver image or it has cancer or not, classifying it. So they have done a pretty good job here. Okay, so still the training is like going on. You people can just use this teachable machine and see. You will finally get model ready here, and you randomly download any image. You'll have an upload button here. You try to upload it. You have cat and dog. So if you upload a dog label, you should get 100% here in dog, and it means if it is anything above 90%, it's like saying that it is a dog image, right? So here again, if you are getting the confidence level more or the percentage more for the cat label, then it is classified as the cat. Okay, so with this, I hope you would have understood or gained something of how coding in ML differs from your traditional programming. And here we are like practicing it every day, every semester through different projects here. So I hope you people just take this up. Machine learning, since it's the buzzword here, machine learning, AI. So you keep on hearing all these buzzwords. So I think it would have created some curiosity in just taking up ML or DL and getting to know what actually and how actually machine learns. So thank you for your patient listening, and do try this teachable machine and see. And sorry, still the training is going on. Thank you, and all the best. Best wishes.
Thank you, ma'am. Thank you for the informative session. It was a well explained session, ma'am. And for the viewers, if you have any doubts related to this session, you can just mail us to uh, the DOA outreach at amrita.edu. We'll answer your queries. Thank you, ma'am. We are with this. We are winding up today's session. We'll meet again for the third series tomorrow. Thank you all.
Thank you. Have a
Thank you,
wonderful
ma'am.
day. Thank you.
Thank you, ma'am.